So series and parallel circuits are two types of arrangements of components in a circuit. And so you can see here, we've got a series circuit, which I liken to a TV series that you watch the episodes in order, and our light bulbs are in order in our series circuit. And our parallel circuit, each of the two branches are in parallel lines, effectively. However, there are some key rules that you're expected to learn about when you come across these, and they are to do with the current, the voltage, and the resistance. And you just need to remember these rules, and I'll go through them once briefly. So if you imagine electrons leaving a series circuit, they can travel around the circuit, and it wouldn't matter wherever you tested in that circuit, the current is always going to be the same anywhere in the circuit. In a parallel circuit, there is a branch, and so what we find in a parallel circuit is the current gets shared by each branch. Okay? So that is the first important rule. The current is shared. And sometimes the Kiss-free analogy of each electron carrying a pot of energy can be helpful here. In a series circuit, as they carry that energy to the light bulbs, they need to share that energy between each of the light bulbs. So the voltage is distributed over both bulbs. So if we had 6 volts given out at the start, each of these light bulbs would have 3 volts each, and effectively be half as bright as they could be as if there was only one in the circuit. In a parallel circuit, it's a little bit different. Each little electron is effectively giving all of its energy to each light bulb, and so in this case, the voltage, potential difference, stays the same. So if I measure one of them, I'd find that that one light bulb is also working at 6 volts. It's giving out its maximum brightness, and it'll be the same as the other one. So the voltage in a parallel circuit is the same at either of the branches. Watch out for combination circuits where you might have, say, 2 light bulbs on one of the branches, and you need to treat this second branch as a series circuit. Finally, the bit that's definitely new at GCSE is the role of resistors. And again, it's not too difficult. I just need to remember some key rules. So in this one, don't be confused by the voltmeter down here. The voltmeter, it looks like a parallel circuit, and we do say we add a voltmeter in parallel. So in this circuit, I've got 2 resistors, 2 rectangles, and they're each slowing down electricity. And so very simply, the rule is if each of these has a certain value, we just add them up, because each electron's got to get past one and then get past another. Imagine you are in the supermarket and you've just brought some sweets, and you pay at the first checkout and queue up, and it slows you down, and then as you're leaving, the security guard checks you, and you once again got to queue up at the second security guard, and it slows you down even more. It's much the same for a series circuit. So resistance in a series circuit adds up. What about in a parallel circuit? Well, this is slightly different because this time there's different routes that you might go. Again, imagine you're in Tesco's and you've got the slowest, worst checkout operator sat on one of the tills. And you then add in a second, really ultra slow checkout worker. Well, if there was 2 customers originally queuing, it doesn't matter how slow the second checkout operator is, there's an alternative route for one of the customers to go down, and that will speed things up overall, even in this case, very slowly. And so the resistance in a parallel circuit doesn't have an actual number. We just tend to say it is less than the greatest number. So if we have 10 ohms and 10 ohms, all we know, we can't give an exact number, is the total resistance of the whole circuit is less than 10 ohms in this case. So it's less than the smallest resistor in that circuit. Okay. Right, forgive me, I did say the greatest one the first time, it's the smallest one.